At the end of the 19th century, physicists have managed to pin down most of the physical world's concepts. They also have managed to form an equation for each of these concepts: electricity, magnetism, gases, optics, and statistical mechanics. Scientists thought they had it all figured out. They thought that nothing else in the physical world was left to prove or discover. So many scientists contributed to the physics and physical concepts we are studying every day at our schools. J. Willard Gibbs is one of those scientists. A modest buried genius, he passed through the whole of his life unnoticed. He spent his first 10 years in Yale without even bothering to draw a salary. In 1871, he joined the university as a professor. His classes attracted slightly over one student each semester. In 1875 to 1878, he produced a series of papers on the principles of thermodynamics. A new age dawned when there appeared the papers of a young scientist that had no university affiliation. He was Albert Einstein. In 1905, he published 5 papers, one examining the photoelectric effect. It explained the nature of light and eventually won him a Nobel Prize. Another one was on the behavior of small suspended particles, what came to be known as the Brownian motion. This proved that atoms do exist. And a third one on the special theory of relativity. This theory merely changed the world. The theory remained unnoticed until 1919. At that time, the theory had the reputation of being impossible for an ordinary person to grasp. What relativity said was that space and time are not absolute, but relative to both the observer and to the thing being observed. And the faster one moves, the more pronounced these effects become. Time was explained as part of the space. It was variable and had a shape. Imagine something pliant as a mattress on which a heavy round object is resting. The weight of the heavy object causes the material on which it is resting to stretch and sag slightly. This is roughly the effect of the sun, which is the object, on space-time, which is the material. The theory suggested that the universe must be expanding or contracting. The paper was followed by a supplement containing Einstein's famous equation E equals mc squared. In the simplest way, it's said that mass and energy have an equivalence. They are two forms of the same thing. The equation most importantly solved the problem of the luminiferous ether. It made it clear that it didn't exist. Einstein then turned to the problem of gravity. In 1917, he published his paper on gravity, investigating what happened when light encountered an obstacle such as gravity. This was the end of Einstein's era. Scientists then carried on from where Einstein left. Vesto Melvin Slipher, born on November 11, 1875, was an American astronomer. He spent his entire career at Lowell Observatory in Flagstaff, Arizona. Promoted to assistant director in 1915, acting director from 1916, and finally director from 1926 until his retirement in 1952. Slipher took spectrographic readings of distant stars and discovered that the stars appeared to be moving away from us. The universe was not static as we thought before. Slipher was the first to notice Doppler shift effect with the light and to realize its potential importance for understanding the motions of the cosmos. Slipher was unaware of Einstein's theory of relativity, and the world was unaware of Slipher, so his finding had no real impact. Edwin Hubble was born in 1889, 10 years after Einstein, in a small Missouri town on the edge of the Ozarks, and grew up there. He was an American astronomer who profoundly changed the understanding of the universe by confirming the existence of galaxies other than our own, the Milky Way. Hubble tackled two of the most fundamental questions of the universe: how old is it and how big? Combining Leavitt's cosmic yardstick with Vesto Slipher's handy redshifts, Edwin Hubble now began to measure selected points in space with a fresh eye. He found out that the universe was truly expanding in all directions. In 1924, he produced a landmark paper, Cepheids in Spiral Nebula, showing that the universe consisted not just of the Milky Way, but of lots of independent galaxies, many of them bigger than the Milky Way and much more distant. All these theories built up, giving birth to new theories that are introduced to us every once in a while, most important the Big Bang Theory. All of these scientists made the physical world what it is today. Science is a collaborative work, and the work builds up and deepens our understanding of the world every day.